I welcome back to the Shuko Math Practice Lab, learning through practicing. And in this practice set, we are talking about one of the very, very useful rules, the substitution rules for the integration. And this is our second practice set. And in this practice set, we're going to see some kind of a little bit of tricks how to we do the substitution. The video number one we did is a pretty standard one. It's kind of straightforward. And so for this ones here, some of the problems we might need to take a look how do we can get it, right? So for this ones here, we're going to work on the 5 problems here. So the 3 of them is kind of a pretty straightforward, and then the 2 of them require a little tricks there. Okay, so now let's go ahead and get started. Let me go to our work here. Okay, so now let's go ahead and get started here. Okay, so for the first ones here, we have the EX plus 1. So first things here, we say, what will be my function, right? That's what we always do. So probably I will do this 1 over, the 1 over x, because I kind of know that 1 over x is the natural of x, right? So now, after you decide this, then you need to decide what will be your u. So you say, hey, maybe this will be the u. Then the remaining one will just be so this is EX dx. So you made your decisions, right? Now, let's try to see if we can match it or not, right? So, okay, so the first thing I will say U is equal to the EX plus 1, right? So the du will be what? EX dx. Ha. You say, hey, probably we made the right decision because this EX dx match, right? So now let's try to rewrite this ones here. Okay, so this 1 over, what is this? Aha, this is my functions, right? So this is my function. And now the bottom is what? Is u. And the EX dx is what? Is du, right? So it's 1 over u du. Wow, this one, we know how to take integration. So what is this one? Is natural log u, right? Plus c. And because EX is always positive, you don't really need the absolute value, then you substitute back. So this is the natural log EX plus 1 plus what? Plus c. So this one is pretty straightforward, okay? Now let's take a look at the second ones here. The second one, you have a tangent and you have a secant. So immediately let it register to you, the derivative of the tangent is equal to secant square. So probably, so here you will see here, okay, you say, hey, so maybe my function will be the exponential function. And then my u will be tangent. Okay, so after you mark it, so what is the remaining terms? You have a remaining secant square and the dx. So let's see, will this work? All right, so let's see here. So u is equal to the tangent x. Right, then you say du, we know the tangent, you take the derivative is what? It's secant square x dx. Haha, you see, oh, wow, this good, right? So these two matches here. So you probably get the right choices here. Now let's try to write it. Then you say, okay, now let me write it. So this one's here will be E is what? E is my functions, right? So it's still here. Then EU is, so it's EU. Then all this light purple is what? It's DU. Whoa, that's beautiful. So what is the EU? You take the integration, will just be itself, right? So it's EU plus C. Then don't forget what you need to do, substitute back what you have here. So EU tangent x plus C. All right. Okay, now let's take a look at this one. This one, immediately you will say here, all right, probably because the bottom have a higher power than here, so probably this will be my function. 1 over something. And then you will say this is 1 plus x squared. And then the order remaining here, 1 plus x dx. Okay, now let's see where this work. Okay, so what is work? Okay, so you said, okay, u is equal to 1 plus x squared. Okay, then you say du is equal to 2x dx. All right, huh. All right, so you go back here, then you check here, right? So you say, okay, 2x dx, but my remaining is 1 plus x dx. It doesn't match, okay? So it does not match. So maybe I need to do something different. But you see here, you said, this is 1 plus x squared, right? So in here you say, if I do not have this one, all right, so if I don't have this term, what I have here is x over dx, 1 plus x squared, then it will work. So the trouble one is this one. So we say, okay, I need to figure out a way to what? To get rid of it, right? So let's see here. Do we have any other choices here? Because I know the 1 plus x squared, it might work if this one is not there. So let's think about it. So before we do it, so this one's here. Okay, so let me do a little bit of trick here. So I can separate this fraction. Can I separate it like this? Yeah, here is the common denominators, right? Then I can just separate like that. So if this is the one, then you can separate this is like 1 over 1 plus x squared dx. Then plus here, this is x 1 plus x squared dx. Wow, did you see something? Yes, what is that? Hey, this term is what? This term is the integration for what? This is the arctans, right? So this is arctan x, right? So this is arctan. So you say, oh, okay, well, I separate this one. I don't even need to use substitution because this is basic or formula. Now, for this is the one, then you try again. You say, okay, my function will be here. And now this is my u. Oops. Okay, so this will be my u. All right, so this will be my u. Oh, I erased my word also, so it's 1 plus x squared, right? So this is by u. Then what is the remaining? The remaining is x dx here, right? So let's try again to see this one work or not. So you see u is equal to 1 plus x squared. Then the du is equal to what? 2x dx. Then you say, okay, this is good, x dx here. So what I have extra here? What I have extra here? I have 2 extra here. But that doesn't matter. So I can divide it. I can take care of that. So it's x dx. Wow, that's pretty good. X dx matches, right? Okay, so now let's see this one. How do I write it? So this one will be now in here, 1 plus x is what? Is u, right? Then x dx is what? X dx is du over what? Over 2. So then you can take the 1/2 over. So this is 1 over u du. So what is 1 over u du squared? This is natural log u plus c, correct? Then you substitute back. So what is used here is natural log 1 plus x squared plus c. So now you combine, because I have 2 terms, right? So what is my final answer? The final answer here is my first term is the basic formula. So I have arctangent x plus 1/2 natural log 1 plus x squared plus c. All right. Okay, so this is the one I say is a little tricky. right? Because you know that you need to separate that out into two parts. And because if you directly use the u1 plus x squared equal to u, your top doesn't match. Then you kind of acting like a detective. You say, if top doesn't match, right? So what I can do to make it a match? So you say, hey, I can separate that. And then it turns out you separated the first term turns out to be excellent, right? So it's the arctan, the integration. Okay, so this one is a little bit tricky. Okay, so let's take a look at the next one here. All right, so this one, okay, so let's see what we have here. This is the 1 over x squared, the square root. For these ones here, I think a very obvious, you know, I have to have this square roots to be my function. Okay, because it's 1 over square roots, so square roots is 1/2, so I can use the power rule. Okay, so now here, this is the, oops. Okay, so let's try again. So this is my power rule. And so this is my functions, this, right? Okay, so now what is my remaining here? My remaining is x squared dx. Okay, now let's see here. Will that work? Okay, so let's see here and let's try. Okay, so you will say u is equal to 1 minus x. Then du is equal to what? Negative dx. So you move the negative out, so du is equal to dx. Then you say, oh boy, okay, so let's see if we can write or not, all right? So this is 1 over 1 minus x is u, so this is u to the what? 1/2. All right, the top is x squared, right? So I only have dx here. But in here, I have x squared and dx here. So I know probably, you know, I cannot do that. It's not right, right? So, but if I can just use the dx, but if I can capture the dx, that's fine. So I need to find a way. So this one's here, this x squared cannot include. So how do I change that to u? Then you see here, you say, okay, x squared. How do I do that, right? So the dx, you can say this is negative du. That's fine. So the x squared, I need to change it to u. So how do I do that? So you say, hey, oh, well, I can maybe use this, right? So this one's here will give me x is equal to what? It's 1 minus u, right? So you say, maybe I can change this is x equal to 1 minus u. So I can change this is u to the square. Then you say, why you want to do that? Is there any formula we are familiar with here? Well, obviously not, right? So now, but it's, at least it's all u, so I can do something here. So let's move this negative sign out. This is u 1/2. So 1 minus u squared, I can FOIL it. So I can FOIL this is 1 minus 2u plus mu squared, right, du. Then in here, you can say, okay, this integration, I can really separate to the 3/1. This is 1 over u to the half minus, like this is 2 u to the u to 1/2 du, then plus u square u to the 1/2 du, right? I just separate one big fractions into 3 small fractions. It's just like what we did from the previous one. It's a little tricky there, right? Now let's take a look. Okay, so 1 over u half. This is become what? U to the negative 1/2. I change everything to the power rule. I can use the power rule. So what is u and u half here? So this is u to the what? 1/2, right? So it's 1 minus 1/2 is 1/2. Then what is this ones here? This is 2 minus 1/2. So this is u to the what? 3/2. Now everything is back to what? everything is back to the power rule. So now I can use my power rule. Okay, so now here, okay, so now u to the negative 1/2. So 1/2, negative 1/2 plus 1 is 1/2. So this is u to the 1/2 minus 2. U to the 1/2 plus 1, so it's 3/2. And this is u to the what? 3/2. Then plus 3/2 plus 1, so it's what? It's 5/2. This is u to the what? 5/2. Right? The whole thing plus c here. Okay, now let's try to simplify that. So this is negative. Be careful about negative, positive sign. This is a flip. So this is u to the 1/2. Negative, negative is a plus. So it's a 2. So 3/2 flip. So we give you 1/3 u to the 3/2. Then minus 5/5 flip. So we give you 2/5 here, right? So this is u to the 5/2 plus c. All right, so finally, what you need to do, substitute what is your u's, right? So you will say negative u, this will be 1 minus x to the 1/2 plus 1/3 1 minus x to the 3/2 and the minus 2/5 1 minus x to the what? 5/2 plus c, right? So that will be what? That will be your answers here. Okay, so this ones here is also a little trickier, right? It's because of what? It's because, you know, when you do that, it doesn't match. So if it's not match, you need to think about some way to make it. So like in here, I can, so this is the step, right? So I said, okay, I can change that to all, you know, the all become the variable u. Then I will simplify that to see I can simplify that to a way I'll be able to take the integration. All right. Okay, now let's take a look at these ones here. So the last ones here, this ones here, this is like a second square cosine t. So very possible this will be my u. Correct? Because it's inside there, now I have like the remaining sine and cosine is the derivative relation. So probably this is a good choice. Now what will be my function? My function will be this second square. Then my remaining term, what is my remaining term? Is the sine t dt. Okay, so now let's see where to work. Right? So sometimes we're not sure, right? So we say u is equal to cosine t. Okay, so du is equal to what? Cosine take the derivative is a negative sine t dt. Correct? All right, so cosine derivative is negative sine t dt. Oh, so you say, hey, this is pretty good. Sine t dt I have in here. It's just varied by a negative. So I have a du is equal to sine t dt. Perfect. I match this my, oops. I match my what? My purple ones here, right? Okay, so now my challenge is here. Let's try to write it to see I can write it into a form I'm familiar with. So here, my function is the second square what? Second square u, right? Second square is my function. Then this light purple is du, it's negative. You put a negative du's here, so it's negative du. I know what is the second square integration. What is that? That is your tangent u plus c, right? So it's a tangent take the derivative will give the second square. Now substitute back what is your u. So this is a tangent what? Tangent cosine what? Cosine t plus c. Right? So that will be your solutions here. So the number 5 is not too bad. The number 5 is kind of straightforward. So the two tricky ones is number 3 and number 4, right? So we need to be very careful. After you do that, if you're missing something, so maybe you need to do something to the integration first and to separate that or combine it to make sure every items in the inside integration, you can find it find it, to a place to fit it. All right. Okay, that's it. This is our second practice set. As you can see, we are kind of getting a little bit more complicated, right? So like, especially like number 3, you need to know how to separate. And number 4, also you need to know how to replace the the x back to a u functions, right? And then try to separate that. So those are all those are very good tricks that you can learn and you try to make sure your integration work. Okay, that's it. Okay, have a good day, and I will talk to you in our next video set. Okay, bye. Have a good day. Okay, bye-bye.